Japan lies in the northern Pacific, just off the Asian mainland. Her beautiful coastline is one of the most exquisite in the world. But the seas around Japan can also be cruel when the waves rage and roar. Japan uses her coastline and the sea as important natural resources, so it is no surprise that the country's aircraft manufacturing industry has produced such an epoch-making flying boat as the PXS. The PXS has been developed by Shin Meiwa Industry, an expert in this field. The PXS has made it possible for flying boats to land and take off in rough seas, previously considered an impossibility. Thus, a new chapter has been written in the history of the flying boat, with tremendous prospects for the future. The manufacturers of the PXS deliberately set out to design an aircraft for use in rough, unprotected waters. This was achieved through a combination of a very seaworthy hull with short takeoff and landing features. The takeoff and landing speed of the PXS is extremely low, even in rough weather. The development of the PXS was focused around increased seaworthiness. The speed of landing and takeoff had to be kept as low as possible. To do this, it was necessary to increase the lift. For this purpose, the most modern devices were used. One of these devices is the deflection of the propeller slipstream. As it passes over the wing, the slipstream of the propeller is deflected by the flaps, thus generating lift. In the PXS, such lift is maximized, and at speeds of up to 45 knots is between 80 and 120% of the propeller's thrust. Another high lift device is boundary layer control, BLC. Flaps at full deflection can cause separation of the air so that the aircraft will stall. By blowing compressed air onto the surface of the flap, separation of the air is prevented. This is known as the BLC system. A wind tunnel demonstration of the BLC system. The energy exerted by the compressed air on the flap generates extremely high lift. The engine and the compressor for the BLC system are fitted in the hull. At low speeds, compressed air is passed over every control surface to maintain lift and prevent stalling. The 1,250 horsepower turboshaft engine and the air compressor for the BLC system. The combination of these two high lift devices gives the PXS a maximum lift coefficient of 7, approximately 2.5 times that of the average aircraft, enabling the PXS to remain fully stable and controllable even at so low a speed as 45 knots. This extremely low stalling speed also has the advantage of providing a certain amount of shock absorption at the time of landing, which was also a key consideration in the design of the hull. The sleek hull of the PXS has a length-to-beam ratio of 12:1. This figure gives an indication of the small impact on landing. In addition to the sleek hull, there is also a groove on each side of the hull along the chine line. These grooves are spray suppressors, a unique feature of the PXS. In conventional flying boats, the bow wave on landing breaks over the hull, causing damage to propellers, engines and wings. Spray also reduces the performance of the aircraft at the time of landing and takeoff by reducing visibility. The spray suppressors of the PXS break the wave before it immerses the hull, so that this is no longer a problem for this new STOL flying boat. The spray suppressors virtually eliminate the effects of spray, which had been the main reason for the decline of the flying boat in recent years. With its excellent STOL performance and hull specially designed to absorb landing shock, the PXS has revived universal interest in the future application of the flying boat. The smooth takeoff of the PXS. Spray is almost non-existent and the aircraft is airborne very shortly after starting the takeoff run. The slow motion camera shows the beauty of the takeoff even more perfectly. Performance of the PXS on takeoff and landing is indeed superb. Short run, short time, and extremely low speed. By solving the problems of takeoff and landing, the PXS will surely revive the golden age of the flying boat. The superb performance of the PXS is an eloquent testimony to the technological excellence of Shin Meiwa industry. Plant of Shin Meiwa industry, occupying a corner of Osaka International Airport. The technology used to produce highly advanced land planes at this plant has inspired and greatly contributed to the development and perfection of the PXS. This is the Konan plant, where a variety of flying boats has been developed. At this plant, the world-famous flying boat Emily was developed by Kawanishi Aircraft, the predecessors of Shin Meiwa industry. The plant, located in Kobe, facing Osaka Bay, has also assisted in the manufacture of the first Japanese turbo-engine medium transport land plane, the YS-11. In addition to the development of the PXS, the plant also overhauls seaplanes and amphibians of many types. development of the PXS began in 1953, when, after a lapse of 8 years, the aircraft industry was restarted in Japan, and Shin-Meiwa Industry started work on a new flying boat with high seaworthiness based on their 30 years' experience in this field. In 1958, the design concept for a combination of spray suppressors and high-lift devices was decided. The soundness of the design concept was demonstrated in the test flights of the UF-XS, an experimental flying boat built on a reduced scale of 3/4 of the PXS, and the basic design was completed in 1964. In 1966, assembly began of a full-scale structure for strength tests. Various tests were conducted to check performance and design until the completion of the final design. Four 2,850 horsepower turboprop engines are used. As is common with all STOL aircraft, the engines must have a very large reserve of power. Structural tests of airframe strength were conducted on the basis of the US military specifications, and extremely satisfactory results were obtained. The hull is of semi-rigid structure to reduce weight and also to increase strength to withstand landing impact. The durability of the hull was amply demonstrated by the results of various tests, including a fatigue failure test. The prototype PXS being assembled at the Konan plant. Complete production contract arrangements have been concluded with a group of well-known Japanese aircraft manufacturing companies. The outer wings and tailplane are manufactured by Fuji Heavy Industries. Japan Aircraft Manufacturing is responsible for the center wing. The engines are manufactured by Ishikawajima Harima Heavy Industries under license from US General Electric. Sumitomo Precision Industry is in charge of the propellers. And now back to the Konan plant of Shin-Meiwa Industry, where the aircraft gradually take shape. The outer wings. The unique T-shaped tailplane. The four engines are mounted. And the propellers attached. The giant airframe is the largest ever made in Japan. The radome. The interior of the first production model is now being fitted out, and the second will soon follow the first. Fitting out is a complicated business. Highly sensitive electronic and other instruments form the aircraft's nerve center. The prototype is nearly completed. Vibration test by simulation of in-flight vibration to see that there are no weak points anywhere. The first retractable beaching gear ever to be installed in a large flying boat enables the PXS to launch and beach under its own power. This has made the handling of the PXS very easy and simple. In fact, it can be handled in exactly the same way as a land plane. (1967). 15 years after the basic research started, and the prototype PXS is completed. Ground tests are very carefully conducted. The propulsion system, being the heart of the aircraft, is tested very rigorously. The engines are in perfect order. All control surfaces are tested. Maximum flap deflection is 80 degrees. Compressed air is blown onto the back of the deflected flap from slots by the BLC system. The slats of the main wing and tailplane extend automatically when the main wing flaps are deflected to increase lift and stability at low speeds. The main feature of the tail assembly is that both elevators and rudder have apparatus to change lever ratio. This increases the degree of deflection of the tail control surfaces during STOL configuration to twice that during cruising, in order to increase the effect of the elevators and rudder. The use of this apparatus in the tail assembly of the PXS is another first in flying boat design. When the rigorous ground tests are completed, the PXS is ready for its first test flight. Ready for takeoff. During test flights, full data on the performance of the aircraft on the water and in the air are collected and analyzed. In spite of its large size, the PXS maneuvers quite easily on the water. A small radius turn leaves a beautiful curved wake. The aircraft completes a pivot turn very quickly by the use of the variable pitch propellers. A pivot turn while moving astern. Emergency braking and reversing can of course be done quite easily with these variable pitch propellers. The maneuverability of the aircraft on the water is quite remarkable, enabling it to be operated in restricted spaces. "59 company test flights, totaling 147 flying hours, were conducted on the prototype PXS.
Roger, go ahead. Roger, you are use number 1. Go ahead. 6W6 depot of those. Roger, you clear to land, Godman will pass you in 3, 6 knots.
In the meter control room at the Conan plant, all the data of the test flights can be watched and recorded simultaneously. These test flights confirmed the designed performance of the PXS flying boat. The excellent stability and maneuverability during flight were also confirmed by the test flights. Safe and easy operation in the air is achieved through automatic stability equipment and autopilot in the flight control system. Stability and maneuverability at minimum flying speeds are the outstanding features of the PXS. STOL is achieved by an harmonious combination of high-lift devices, balance between control surfaces, the BLC system, automatic stability equipment, and increased deflection by lever ratio change of elevators and rudder. which has excellent STOL capability, can be operated in restricted waters and does not require costly airport installations like land planes. The great utility of the PXS will open up new fields for aircraft, and Shin-Meiwa Industry will fit it out for various specialized uses, such as search and rescue in rough seas, STOL civil transport, supplies for isolated and mountain areas, meteorological observation, and so on. Waves and wind have been the biggest obstacles in the development of the flying boat, and their subjugation had been considered a dream. Takeoff and landing tests of the PXS were conducted in rough seas. On the day of the tests, the waves in the area reached a height of 13 feet. The PXS has been developed with the conquest of rough seas as its main objective, and it has been made sufficiently seaworthy to maneuver in the open ocean. But one picture is worth 1,000 words. It was considered that flying boats could be utilized in the open sea on only 100 days a year. The PXS has raised this figure to approximately 300 days, resulting in a considerably increased rate of operation for flying boats. No other flying boat in the world has attracted so much attention as the PXS. No other flying boat in the world promises so much as the PXS. Performance and utility far outclass any flying boat ever built. The PXS completely satisfies every demand asked of a flying boat. Shin-Meiwa Industries PXS has opened a new chapter in man's conquest of the air.